right, so now we've connected our X limit switch and our Y limit switch for the ChronoSync device, and we've also connected our servo, Z-axis servo. So now we will connect the stepper motors that you see here on the left and right. So I've inserted the connector over here into the stepper motor. There's only one way you can put it in. It won't go in the other way. So you have to insert it this way. And then on this side, you need to have the black cable, the black side, so black, green, blue, red, inserted this way. So the orientation should match. You should not put it in this way. This will cause problems. You need to make sure when you insert the wires from the stepper motor, it goes in black, green, blue, red. Black, green, blue, red. And then the one on the left, this is the orientation. The letter should be this way. It should be readable. And then the right side motor goes into the Y2 position, and the left side motor over here, the cable for that goes into the X axis slot here. Again, black should be the leftmost cable, so push it all the way in. Black, black, green, blue, red. All right, so now we've completely wired up our XYZ robot. Now we'll connect it to power and the USB, make the USB connection. So connect it to USB, then connect the power with the supplied adapter. All right, now we'll go to our serial monitor and type in H, but with a 5-second delay, so I can film it more easily. 5-second delay and then H. So this should move our robot into the home position. So let's go, press enter, and then let's see, does it go home? Yes, it does go home. So what else can we do? Well, we can try moving the robot to different positions, and also read the position of at a specific point. So I'll give you an example. Let's first try to move the robot. You can see I can't move it. The reason is the stepper motors are engaged, and once they're engaged and powered up, you cannot move it. And if you try to move the robot, you will damage the stepper motors. So what you need to do is type in D. D is the command that disables the motors, this function here. So we just type in D, that disables our motors, and now we can freely move it. So suppose I want to know the coordinates of the robot at this position, right? So suppose I have some tube, the liquid has to be deposited there, and I want to know the coordinates of that tube. I just move it in place like this. Of course, if you do move it, you want the tube up, so we just do T1. So the tube up, move it in position somewhere here, and now we'll do C. So C is the command that gets you the coordinates from that position. So I'll just type in C and press enter. But yeah, let's put in a time delay first, 5 seconds. All right, so that should tell us the coordinates of this position. Goes home, and now we have the coordinates, and they're about minus 12,192 and minus 11,424. So this is one way you can get the coordinates for the robot. You can also do multiple movements. So for example, I can move it to this coordinate and this coordinate, then this coordinate and this coordinate, and so on, and then get the robot back home and get the final coordinates from here. So our program coordinates are minus 5,000, minus 5,000. So our measured coordinates should be close to that number. It's not always perfect. There might be some small error, but generally it's pretty close. Let's add a delay of 5 seconds first. And then the pipe operator you see here, that's how I separate the different commands together. So you can string several commands together and then just send them. So 5 seconds, and then let's see. All right, so that's our XYZ robot. It's working perfectly as expected. And now we can simply control our robot using serial commands sent to our Arduino board here. And we can do that through Jupyter Notebooks, and that's coming up next.